In this video, we're going to talk about how to multiply binomial radicals. So remember, we learned how to multiply binomials using FOIL. So remember, FOIL tells us we multiply the first term of each, and that's how we got x squared. Multiply the outside, so x times 3 gave us 3x. Multiply the inside, 2 times x, which is 2x, and then multiply the last term, 2 times 3, which is 6. Then we finally add up all the terms, and so we get x squared plus 3x plus 2x plus 6, and then we combine any like terms, so we combine 3x and 2x, and that's how we got 5x. So our final answer is x squared plus 5x plus 6. So sometimes we'll have radicals that look like binomials, and we can use FOIL to multiply these binomial radical expressions. So you can see here we have 4 square root of 3 plus 5 square root of 2, right? These have to be separated by a plus sign because they're unlike radicals. And then we have 3 square root of 2 minus 6. So these also have to be separated by a minus sign because you can't combine a 6 with a square root of 2. So what I did here was I used FOIL to multiply these together. So you just treat these radicals like terms. So you do 4 square root of 3 times 3 square root of 2, right? And that's how we get our first expression. So we do 4 times 3, which is 12, and then square root of 3 times 2, which is 6. Then we do the outside terms. So the outside terms will be 4 square root of 3 and minus 6. So when we multiply these together, we do 4 times negative 6, which is negative 24, and then that square root of 3 just stays as it is. Then we do the inside terms, which are 5 square root of 2 and 3 square root of 2. Well, when we multiply 5 square root of 2 times 3 square root of 2, we get 5 times 3, which is 15, and then square root of 2 times 2, which is the square root of 4. The square root of 4 is 2, so when we do 15 times 2, that's how we get 30. And then finally, we do the last terms. So we do 5 square root of 2 times negative 6. So 5 times negative 6 gives us negative 30, and then we have the square root of 2. Then our last step will be to add up all these terms. So we have 12 square root of 6 minus 24 square root of 3 plus 30 minus 30 square root of 2. Notice that these are all unlike terms, so that's why we just have to leave them like this. So you can also multiply radicals in the TI, and you can use your calculator to multiply. However, what happens is it gives your answer as a decimal, and it won't give your answer in radical form. So it's better to use it to check your answer. So for example, I just did this previous problem in my calculator, and I showed you the screenshot. So it tells me negative 24.6. If you want to check your answer here, you can type in this final answer and see that it does in fact give you the same decimal. Okay, so you can use your calculator to check, but like I said, it won't give you your answer because it's not in radical form. So when we're multiplying binomial radicals, we use FOIL to multiply the terms. Remember to simplify any products whenever possible, and then add the terms, remembering to combine like terms. You can always use your calculator to check your answer. So let's try multiplying these two binomial radicals. So I'm going to use FOIL. So first is going to be 6 square root of 3 times 2 square root of 5. Okay, so 6 times 2, that's going to stay on the outside, that's 12. And then I have the square root of 3 times 5, which is 15. Now let's do the outside terms. So outside I have 6 square root of 3 times 4 square root of 2. So let's multiply what's on the outside. 6 times 4 is 24. And then I have the square root of 3 times 2, which is 6. Now let's look at the inside terms. So we have minus 5 times 2 square root of 5. So negative 5 times 2 square root of 5. That's going to be negative 5 times 2, which is negative 10. The square root of 5 doesn't have anything to multiply with, so I just leave it. And then now finally our last terms, we have negative 5 times 4 square root of 2. So when we work this out, negative 5 times 4 is going to be negative 20. So we have negative 20 square root of 2. So now our last step is going to be to add up all our terms. So we have 12 square root of 15 plus 24 square root of 6 minus 10 square root of 5 minus 20 square root of 2. Okay, and none of these are like radicals, so we just have to leave our answer like that. So now you can go ahead and pause the video and try doing this example on your own. So when we do these binomials, first times first gives me 4 times 3 square root of 3. That's 12 square root of 3. Then we have outside 4 times 4 square root of 5, so that's going to be 16 square root of 5. Inside 2 square root of 5 times 3 square root of 3, so we have 6 times the square root of 15. Last, 2 square root of 5 times 4 square root of 5, so 2 times 4 is 8. Square root of 5 times 5 is the square root of 25. Well, the square root of 25 is 5, so this is just basically 8 times 5, which is equal to 40. Then in our final step, we add up all our terms, and these are all unlike terms, so I just leave them like this. So remember also we talked about this pattern, the factoring pattern, the difference of squares. So remember we said if we had two perfect squares being subtracted, like x squared minus 36, that was basically x plus 6 times x minus 6. And remember we said the reason is if you FOIL this out, you end up getting x squared plus 6x minus 6x minus 36. Okay, and these two middle terms will cancel each other out, and that's how we end up getting x squared minus 36. So we can extend this idea to binomial radicals. If we have binomial radicals that look like this, so for example, if we have 2 plus the square root of 3 times 2 minus the square root of 3, these types of radicals are called conjugates. Because notice they have the same terms, it's just that the sign is opposite. So when we multiply these kind of binomials together, we actually can use the difference of squares as a shortcut. We don't have to write out all the terms and use FOIL. We can just know that this is like, if we call this A, and we call this second term B, right? This is like A plus B times A minus B. And so that's going to give us A squared minus B squared, which we know because of the difference of squares. And so that helps us multiply a little bit like a shortcut, right? 2 squared is 4. The square root of 3 squared is just 3, so 4 minus 3 is 1. So for example, if we're multiplying these binomials together, notice that they are conjugates. So I can realize that this is basically A plus B and this is A minus B. So my product is going to be A squared minus B squared. So I can say that my product is basically 7 square root of 2 squared minus 3 square root of 3 squared. So remember when you're squaring a product, this is another one of those exponent properties, both terms inside the product get squared. So we have like 7 squared times the square root of 2 squared. 7 squared is 49. Square root of 2 squared is just going to be 2. And then minus here we have 3 squared times the square root of 3 squared. Well, that's going to be 9, right? 3 squared is 9, and the square root of 3 squared is 3. So we have 49 times 2. And so 49 times 2 is going to be 98 minus 9 times 3, which is 27. So we have 98 minus 27, which is 71, and that's our final answer. So now you can go ahead and pause the video and try doing this example on your own. So here you can recognize that these are conjugates, so we can use our A squared minus B squared as our shortcut, right? Because this is A plus B, this is A minus B. So we have 8 square root of 5 squared, so that's 8 squared times the square root of 5 squared. So that's 64 times 5. 64 times 5 is 320. And then here we have 6 squared of 3 squared, so that's 6 squared times the square root of 3 squared. 6 squared is 36. 36 times 3 gives us 108. So now our final step is to do 320 minus 108, which gives us 212. So remember, you can multiply binomial radicals using FOIL. If the radicals are conjugates, you can use the difference of squares as a shortcut for multiplication.